So left endpoints, f of 2 is the height. F of 2.5 is the height. Right endpoints, f of 4 is the height. F of 3.5 is the height. And you only need 4 of them. Then when you want midpoints, you got to take the actual midpoints. You have to get the midpoints.
Okay.
So in this case, since across here is a half, you only want to go halfway across. So the first one is 2 1/4.
Okay.
So it's not going to be any of these.
Okay.
So midpoint in this case is 2.25. But now, once you go to the 2.25, you need to move a full delta x to get to the next one.
Okay.
So the first one's a little off, right? The first one you can use is a little off.
2.25.
2.25, and now you need to add the delta x to get to the next mid.
Which is 2.75.
Right.
Okay.
And just keep adding delta x's after that.
Okay, that makes sense.
So let me just get the number 2.75, 3.25.
Then 3.75.
Sounds good. You only need
And
4,
so,
right?
and for the midpoint, where would you start? Would you still start from the leftmost?
It doesn't really matter either way. You can start from 4 and subtract a quarter and get you to 3.75, and then subtract
Okay.
1/2, 1/2, 1/2 till you get to the last
Okay.
one. Yeah. Anything else?
Yeah,
Let's
but
do-
the same thing for number 6 on the
Number 6. It says the same thing, or
It's just the midpoints.
it's midpoints.
Yeah.
What are the values?
Well, the equation is cosine of t divided by 2.
Cotan of t on 2.
Which one?
Cosine
Oh, there's a
5.1 or
cosine.
5.2?
of t divided by 2 minus pi divided by 8.
Minus pi. That's the function.
Yeah.
Okay.
And then it's from 0 to pi.
0 to pi.
N equals 4.
N equals 4.
Yeah.
You just want the midpoints you're going to use. The book has a formula for it. I don't really use the formula so much. I just kind of think about it a little bit. But we need 4 rectangles again. So the grid points are going to be 0, pi on 2, pi on, remembering, 3 pi on 2. No, what am I saying?
What?
No, no, sorry. I went too far. Pi on 4, that's there. Pi on 2, 3 pi on 4, and pi. There's the 5 grid points to create 4 rectangles, right? And again, it's coming from the delta x being pi minus 0 on 4. So I need to move by pi on 4 steps, 4 times. So now if I want the midpoints, I need the midpoint between each of these, right? Midpoint between each of these things. So I have 2 options. I could just construct midpoint for each one. I could take 0 plus pi on 4 divided by 2. That'd be the midpoint. I could take the average of every single pair of grid points. I could do that. Or like I was saying a second ago, since you know that to get halfway between these two is pi on 8, once I've gotten that one, to get over to the next midpoint, I will still step by the pi on 4. So pi on 8 plus pi on 4 is 3 pi on 8. So I just keep adding 2 pi's on 8 in this case. So 5 pi on 8 and 7 pi on 8 are the 4 midpoints you would use. Yeah? Does that make sense the second time?
Let's
Well.
do 5.1.
1 second, just to raise his hand. What did you say?
Oh, I had a question about 5.2, but
We got another 5.1? Okay.
Let's see, okay. So the velocity of an object moving along a line is given by v equals 4t squared plus 5 feet per second.
Plus 4t squared plus 5 feet per second.
Yep, on the interval 1 less than equal to t less than equal to
1
5.
less than equal to t less than equal to
5.
5.
Alright, so it says divide the interval bracket 1 comma 5 into subintervals.
How many?
So 1, 2, 2, 3, 3, 4, and 4, 5.
Oh,
there's 4.
so break this up into what did you say?
Subintervals.
1 to 2,
Yeah, 1 to 2, and then 2 to
2
3,
to 3,
3 to 4, and then 4 to 5.
4 to 5.
On each subinterval, assume the object is moving at a constant velocity equal to the value of v. Evaluate at the midpoint of the subinterval using approximation to estimate the displacement of the object on 1, 5 bracket.
We said use midpoints though? Is that what we said?
It says it.
Yeah, it says using midpoint
Yeah.
as the subinterval.
Okay. That whole constant business, the thing about the velocity being constant, you know it's not constant. It's 4t squared plus 5. The reason they're saying assume it's constant on each of the subintervals is because once you plug the midpoint value in here, that gives you some constant. That's the value you're using for each subinterval.
Yeah.
So you need to know what between 1 and 2 is. So 1 and 2 is 1.5.
Yeah. 1.5.
So 3 halves, and between 2 and 3 is what?
2
5 halves? Okay, 5 halves. Looks like there's a pattern here. 7 halves, and 9 halves. Okay? So there's your 4 midpoints, 1 for each of the respective intervals. So now all you're doing is you're going to take each of these 4 and you're going to plug them into the V. So V of 3 halves, V of 5 halves, and so forth for all 4. So this works out pretty nicely. Each time you square one of these numbers, you get a 4 at the bottom. You can't just put 4 in the expression. So the first one is really just 9 plus 5, which is 14. And 25 plus 5 is 30. 49 plus 5 is 54, I guess. And then 81 plus 5 is 86. So those are the values of V at those 3 locations. So now all you're doing is assuming that on the interval 1, 2, which is length 1, right? The height of that rectangle is 14. That's all it's saying. So all of these here that you're computing right here, these are all the heights. And 5 minus 1 on 4, right, the delta x, they already gave you here. You know it's 1, 2, 3, 4. It's 5 minus 1 on 4, because you're using 4 rectangles. So it's 1. So there's your 4 heights, and there's your 4 breadths of each rectangle. Okay? So when you want to compute this now, you're just going to take 14 times 1 plus, I'm just writing it like this in case it was not such a simple computation, plus 54 times 1 plus 86 times 1. So you just add those all together. So 14 and 54 is 69.
184.
Okay, if you say so. 184. So that's your estimation at what? At what the distance traveled is. Right?
So
Why is it distance traveled? Because you were taking velocities, which are given in feet per second, like they said, and you're multiplying by delta x, or in this case, that should be more proper, delta t, so delta t's. So you're taking feet per second and you're multiplying by seconds. So what do you get by feet per second times second?
Feet.
Feet, that's right. So each of these, the non-units, 14, 30, 54, and 86, they're all velocities, and each of the ones is really 1 second. So each of these products here are all in feet, and you're adding a bunch of feet. So it's displacement.
So that is 4 subintervals. Now here we have part B is for n equals to 8 subintervals.
Repeat process.
Repeat process.
You would
Process.
do that, or you would change the t over 8, right? And then you go from there.
Change
The
delta
change of
t.
t, yes, be 5 minus 1 over 8, right?
Correct.
And then you can just go from there, same process.
Right. Now these are gonna.
Change, yeah.
Yeah.
it's 8.
So
Yeah, but the overall process is the same.
Okay.
process the same, but where do I start when I change it?
So start like Justin said. First of all, change this to 5 minus 1 on 8, because you have more rectangles. You have 8 rectangles now.
Okay.
So that'll give you
One
what,
half.
half. Okay. So now that means each of these lengths should be a half. So there'll be 4 more of them. So it's
Okay.
going 1 to 1.5, 1.5 to 2, right?
Okay.
And so forth for each one. You're basically just splitting up each of these